Dear audience, welcome to our webinar about the topic Get More Yield with Smart Arc Vision. In this webinar, you have the chance to ask questions using the chat. We will answer these questions at the very end of the webinar in the Q&A section. And to start, we would like to give you an overview of what can you expect today. At first, we want to set the focus on the detection and understanding of common welding defects. Then secondly, important is in the follow-up how we ensure 100% visual inspection. And finally, data handling. How can we optimize the welding process with smart data integration?
Thank you, Benjamin, for this very short overview. Target of this webinar is also to set impulses and give an overview of our possibilities with regards of the Internet of Things, especially for welding applications. So for today's webinar, we'd like to introduce you the persons who will guide you for this evening. And Benjamin?
Yeah, so let's start with Oliver to my right. He's a key account manager for the automotive industry at Retronic Machine Vision Germany. He's expert in image processing with expertise in AI and deterministic applications.
Thank you. And to my left, dear colleague, also in the key account management for automotive, is Benjamin Schlosser. And he is a welding engineer and truly a great expert in MIG/MAG welding. And dialed in from Mexico, we like to welcome also a dear friend, Angel. Hello. A few words
everyone.
to yourself.
I'm very fine. I'm very happy to be here. First of all, thank you for the invitation, and also thank you for the people that are attending this meeting. If you allow me, I will give a short history about me. I have been working in Fronius since 4 years ago, and during all this time, I have worked with the most demanding customers that we have here. And actually, some of these implementations that we have done with Bytronic was born by requests of customers that we have here. So that is why I am here. And again, thank you for the invitation.
Thank you for joining us, Angel. And we have you here because we think that perspective is key to understand fully all requirements, starting from a solution provider like Fronius is, or like a solution provider we are, the integrators or other stakeholders during the whole welding processes. And perspective is also important to understand how we can detect and understand weld defects. We want to learn more and give you more insights into the common weld defects and what causes them. So we start with the understanding of exactly them. But Benjamin, what are typical welding defects from your perspective, which our customers are asking for?
Our customers are actually, they are both asking for welding defects, but also just for features of their welds. There's, for instance, the throat thickness or the weld length, which is important in terms of the load bearing of the joint. And also, there's a topic of spatter, for instance. That's very important because functional areas might be contaminated. I would also like to explain how we work. So what our sensor does, it's scanning the weld's surface plus the adjacent area, and then we can measure a vast variety of features. We can copy the entire requirements of the standards which are behind the weld quality, and so there's, for instance, the weld toe angle, or when it comes to dynamic loading of parts, the undercut. So there's a large variety. And Yeah, so then I think
Yeah, thank you for the short insight into the common weld defects from our perspective. Now turning it to Fronius. Angel, you can name top 3 typical welding defects which your customers or your applications are always asking for to be avoided. Would be great.
Sure. Well, as everybody knows, we have different defects, and all these are important for customers. But if I have to select some of them, I will go with porosity, undercuts, and lack of fusion, because these defects, it's possible to monitor which causes could provoke these defects. So yeah, I will go with these 3.
And Angel, so like now we have like, let's say like the top 3 of welding defects. Can you name where they come from?
Well, for each welding defect, we are going to deal with multiple causes. We have to research about which conditions are provoking these defects. So, for example, if we are talking about undercuts, we can say that this could be caused by an excessive voltage in some point of the welding, but also this could be caused by, let's say, but the wrong technique in the welding task. But the interesting thing about the undercuts is that we can monitor the voltage, for example, with the process data of Fronius in order to identify if we have a kind of peak during our welding in order to identify these suspicious of undercuts. Also, the porosity is something, well, interesting and very common. The causes, well, it could be a dirty base material that this provokes this disruption or in a stabilization of our welding arc. So also this could be identified or monitoring with the fluctuations of the welding current, but also the gas coverage. If we are using an inadequate gas coverage, it also can provoke or cause the porosity, right? Fortunately, by the process data, we can use the gas flow in order to identify if we are welding with enough gas or not. And talking about lack of fusion or inconsistency of penetration, also we can monitor the welding or the power that we are using during the weld in order to identify if something is not according to our welding standards.
Thank you for that, Angel. And I think it's also to mention that we can add value to the monitoring data or to the monitoring results with a downstreamed visual inspection. This could be very helpful because compared to human inspectors, which would confirm maybe the process data, a visual inspection could deliver stable and reliable inspection results 24/7 and objective, because sometimes human attention is very volatile on daily performance of each individual worker, and comparable data are in short long-term key for sustainable optimization of a whole welding line. So therefore it is important that both systems, the monitoring system and a visual inspection system, can save results digitally for as long as you need it and for consistent documentation. With this idea, Benjamin, what is the advantage maybe to combine visual and process data?
So to answer this question, I would like to have a look at 2 macro graphs. And everyone who's somewhat familiar with Gesma-Del arc building can see, I think, that there's a lack of fusion on either side. So both left and right. And these parts would be either scrap or rework, but like there's a different reason for the same defect. If we take a look at the tool center point, so which tells us like where did the welding gun point to, it shows us on the left the welding gun pointed into the corner, which is correct, but we did have a low heat input, which caused the lack of fusion. On the right, we did have penetration, but there was a bad positioning, and we did receive a lack of fusion towards the upper part. And so like we have two different reasons for one defect. And to come back to your question, so like why is it does it make sense to combine both data? On the right, it's pretty easy to tell from the visual data that it's a defective weld. On the left, it's less easy. And just one remark about these macrographs. They originate from a EU-funded research project named Meter Fixturing. These welds were made on purpose. And so why did we choose this for this webinar? Handling of customer data is a very sensitive topic, so we'd rather choose research data which are not confidential.
I see. Well, thank you for this. And with these first insights in common weld defects, how they come from, we have also to answer the questions how we deliver very reliable and also stable visual data in comparison or for the comparison to the process data. Now we take an example for battery frames and how we acquire the visual results of weld seam defects. If we have a look on battery frames, it's a very big product, and you have different positions, different appearances of weld seams. You have different lengths, and yeah, it's very volatile in the whole application. And you have not only 10 to 20 weld seams, you have many positions. You are having different weld seams, and you need, for example, also laser triangulation system to check for volume, to check for the length of the weld seam. And our robot mounted system ensures that you get all data. However, the weld seams are shaped in real. You can also scan very efficient by just scanning in one line, separate or different weld seams in one row, to visualize also for the operators how and where defects appeared. And you can get also an operating 3D picture to optimize also the rework and show exactly what to do, where to do it, visualized on the part or visualized the defects visualized on one single weld seam. So you can ensure from each visual inspection how the part is rework, what is to do. You have a very efficient workload, you have a very efficient rework process, and therefore a visual inspection can add value to the monitoring of process data of the welding. And I think that the combination is very value adding. And maybe this leads to another question to Angel. Angel, according to your experience, which advantages would you see as a welding automation expert to support welding optimization with visual data?
Sure. Well, in general, I think that Bytronic and Fronius provide information, but how our customers are using this information, it depends of the ingenious of each customer, and also it depends of the needs, right? But if I have to mention a common practice which combine these two solutions, I will say that they usually use this visual data as a trigger in or quality checkpoint. No, so if something or some inconsistency in the seam is identified on with this visual inspection, well, in this point, Bytronic can activate or trigger an alarm in order to tell to the user, let's say to the inspector, that something is not okay, right? And after that, we can use the information from Fronius or from the process data in order to analyze what happened. Okay, so metaphorically speaking, Bytronic or visual data is going to be our alarm, and process data or Fronius data is going to be our video recorded, in order to understand what happened. But at the end, as I already mentioned, welding defect, it would have different causes. So the more information we have, the more accuracy we could have identifying the cause of each welding defect, right? So for example, here in this presentation, we can see that we have some discontinued theme in the end of this weld. So we can correlate this alarm that Bytronic tell us with the information that we have in the process data. That in this case is a current that was not sufficient to reach this, let's say, this width.
Okay, so what I got is we set off the alarm and you do the investigation. That's actually an interesting perspective.
Sure, and as I already mentioned, it's just an example how we can combine this information, because at the end, the information can be used in several ways. But also we can use these bot solutions in the opposite way in order to say, hey, WeldQ Premium, tell me what is wrong in my welds. And yeah, the WeldQ Premium can say, hey, this and this is wrong. Please have a look in the Bytronic documentation in order to see what is happening. And I think that this sharing of information is the point of this collaboration, is give to our customers more information or more tools to identify what is happening. What is happening in the process. So yeah, with this we have some benefits that we could mention after.
Well, I think this is a very wise approach that we together built, and my question would be now also with your experience, which benefits we could obtain from such a solution from WeldLoop and WeldQ that we offer?
Sure. Well, at the end, WeldQ Premium is a checkpoint of the process data, and I see Bytronic system as a quality checkpoint, right? So these checkpoints are going to allow us to identify when a welding defect appears in the first component that is wrong. So this, let's say, this live monitoring allows us to have a look in what is happening in the cell or in the production line, in order to don't produce more components with this welding defect. So of course, if we can anticipate these welding defects in more components, of course, one of the benefits, it could be reduction of rework, reduction of scrap also, and for sure, and stabilization, of the welding process.
Thank you, Angel. I think these are very, very big and good benefits with a huge impact. And I think that key is also to have a smart usage and structuring of data from different sources. This is very important. And this leads us to our final topic. And this is why we want also to focus on how you can optimize with smart data integration. And we would like you to just discover how our software WeldLoop connects to the process data, to improve also the welding quality, and how we can enable real-time monitoring with seamless integration. Yeah.
Exactly, and to focus on this point, I would like to take a look at the example that Angel just showed us in the video. So we could see a weld with a burn through towards the end. So like this is, let's say, the dark spot on the right. And like the orange picture is the visualization of the 3D image of this weld shown in the software WeldLoop. Below, we can see a selection of data that were acquired from this weld. So the first graph does show the weld toe angle, so we can see that the weld toe angle is leaving the desired range. It's exceeding the limit, And at the bottom, we can see the graph of the recorded welding current. So these data, the welding current, together with other welding process data, were handed over from the weld cube, and it's now shown in weld loop. And what we can now see in these data, that the welding current is increasing, it's going up and down, it's beyond the limit. And from these data, we can tell that the burn through was most likely caused, let's say, by the welding parameters in general. So now comes the interesting point. So there's an option to jump right into a software plugin of the weld cube, and so now the question is to Angel. Okay, what can we see in the weld cube interface, and can we find out what caused this burn through?
Well, I have some hypotheses. To be honest, in most of the cases, we need to be there on site in order to do the best verdict. But fortunately, when we have this kind of technologies that allow us to digitalize the production line, we can do this analysis in a remote way, as we can do right now. So yeah, also this is something important to highlight. No, regarding this defect that you mentioned, well, I have some hypotheses. Maybe the robot parameters were changed or something like that.
Yeah, but well, like I can tell that the robot parameters stayed the same, so there was no change in throttle speed or stick out. So like it's like these parameters are constant. There was also nothing happened to the base material.
Okay.
Yep.
So well, maybe on this point we have to have a look in the welding parameters, right? And this is something that we can do directly in the weld loop application, because WeldCube Premium also is included in this interface, and is easy to jump from one application to another one. So in this case, in WeldCube Premium, I can see, or I can have a look in the welding report in order to see which job was used to weld this seam, and also I can see if this job is according to our welding standards. No, also on WeldCube Premium, which is the interface that we are looking here in the presentation, we can have an historic of changes of this job in order to identify if some changes were made. Because, well, at least here in Mexico, it's very common that when something is not right or something is wrong, yeah, normally the first thing that the people do is change the parameters when maybe it's not about the parameters. So WeldCube Premium allows us to have a look if someone did change in the parameters. If not, okay, we can reduce the list of causes in order to identify what happened. So here in this case of this example that Benjamin gave us is regarding the welding end, right? The welding end is too high because someone changed it in some point, and that is why we have a burn throughout in the end of this of this weld, right?
Okay, thank you. This was a very fruitful and informative insight. And I think to wrap it up, what I understood is that we alarmed via the visual data that the defect was there. We did the investigation based on the monitor data. And I think I have to underline that also a very good pragmatic example from one of our customers, where we tried to integrate an inspection solution in a welding line. And what we observed was that the first pass rate without the correlation of monitoring data was, I would say, below 80%, only 75% after 6 weeks. So 6 weeks of optimization, the welding line of getting the defects, and you need very good quality parts. It took too long to investigate and understand how to optimize. And by correlating the monitoring data from WeldCube and from the Weld Loop, so the interface we have, and to correlate these data, we went from 75% within 6 weeks to more than 90% of the first pass rate, which only shows how you can really add value and save time. And time saving is always also based on saving money. Yeah. Beside the less scrap you are producing. And yeah, I think this is really a value-adding combination.
Exactly. I think this is was absolutely a perfect example. And right now, I would like to summarize what we just talked through. So at the beginning, we saw that weld seam inspection system like Viro WSI can provide a 100% visual inspection of weld seams. Together with WeldCube, it allows to track process changes and save data. And we saw as well that combining the data from the welding arc and the visual inspection is a pretty smart combination. So, and finally, we receive digital and reliable features. And Oliver just showed us that this combination allows to increase the yield in the production faster than combined to the normal approach without combining the data. And with that, I would like, first of all, I would like to thank Angel for joining us today in this webinar. Thanks a lot for your input and for the data that you presented. And now it's time to have a look at the questions that were asked by the audience. Okay, so what is a typical product that is inspected automatically? So from our perspective, or like for automated welding inspection, a general answer is these are safety critical parts. And a typical example from the automotive industry are chassis parts. Angel, from your experience, so at which products is the WeldCube Premium maybe applied mostly?
Sure. No, definitely, I agree with your comment. Most of the automotive components has critical welds, and all these critical welds need to have this traceability about who weld this seam and which station with which parameters. So yeah, in general, any automotive component that has critical seams, are important for the customer. Well, I will say that these are the more typical.
Okay, thank you, Angel. So the next question is, can you use visual results to control the welding process? Oliver.
Yeah, well, that's a very interesting one, because we have all data available. We have the process data. We know where a weld was welded, which defects we might have or not have. We have the process data, so process parameters for the welding. It is imaginable that you can control the welding process, maybe not live, but after another weld, to optimize your welding line. So especially maybe also in use for automatic rework, but I think that especially for safety critical results, you have to limit the automation modes you have. I don't know, what do you think, Angel, with the question if you would control automatically or not automatically with visual data the welding process? What is your opinion?
Sure. Well, definitely on live is not possible right now. We have to weld and then identify the defect in order to take the next steps. So yeah, right now in live, no. but at least if we let's say if we notice a frequency of weld defects in, let's say, 2 components or 3 components, in that point we can take an action in order to don't weld more than, I don't know, 10, 20 components with these welding defects. But definitely, I think that this is the next step. I think that this is the direction that we need to, that we need to scope. So yeah, hopefully we can do that in the future.
Hopefully, yes. Well, thank you for that. And we have also one last question. It's an interesting one because we have a fast-living world. Yeah, Angel and Benjamin, how fast are the data from Weltloop and Weltcube available? How fast is it? Do I have to wait one day until I have the data available, or what is it?
So I would say like now or instantly. Well, like to answer it a little bit more technically, well, like the data are transferred by the field bus, so it's depending on the speed of the field bus, but actually like right now.
Yeah.
So like, or Angel, well, like how would you answer the question?
Yes. At the end, between Bytronic and Weltcube Premium, there are, let's say, there is a black box that we don't know what is inside. Of course, we know that there are cables, there are switches, there are security protocols, etc. But the point is that on this black box is going to, let's say, affect how much time is going to take to give the information from Bytronic to Weltcube. So it depends. In my case, I have tried it, and I don't have to wait more than 5 seconds to just refresh in Weltcube Premium the inspection, and I can see the evaluation of Bytronic. But yeah, definitely depends what is between Bytronic, or let's say between Virosystem and Weltcube Premium.
Perfect. Thank you for that. I think in that case we had a short summary. We had questions answered and hopefully answered to your satisfaction. We would like to thank you, Angel, for your participation in this webinar. The audience, we would like to thank you for your patience and your interest in our webinar. And if you have any questions, do not hesitate to contact Angel, Benjamin, or myself. We are available on LinkedIn. We have shared our contact data also on the homepage. And maybe also from Benjamin and Angel, some last words to this webinar.
So I hope that we could motivate somebody or some people to think about integrating more data and making more use of their data.
And use the data which are already available.
Yeah. Exactly, like use data which are already there. And so in case like there are any questions, feel free to contact us. And Angel?
Sure. I would like to add just that if you are a company that are looking for a Industry 4.0, I think that you need to have a look in the providers or the companies that are collaborating in order to reach this goal, because it's the only way. This collaboration is that simple, about collaboration of different companies in order to reach the same goal. So yeah, I hope this could be or this presentation was interested for you. If you have questions, yes, you can contact me without problems, or you can contact the corresponding representative from us from your country. Yeah, it was a pleasure for me, Benjamin, Oliver.
Also for us. Thank you.
Exactly.
Thank you, guys.